I'll be solving Chapter 3, Problem 50 out of the Heat and Mass Transfer 6th edition book. Our problem statement is that the thermal contact conductance at the interface of two 1 centimeter thick aluminum plates is measured to be 11,000 watts per meter squared Kelvin. We are supposed to determine the thickness of the aluminum plate whose thermal resistance is equal to the thermal resistance of the interface between the two plates. To solve this, we're going to use the equation that our thermal resistance is equal to the thickness of our plane wall divided by our thermal conductivity. And this is also equivalent to 1 over our thermal contact conductance. We are told the material is aluminum and the thermal contact conductance is 11,000 watts per meter squared Kelvin. Because we know the material is aluminum, we are also able to determine that the thermal conductivity is 176 watts per meters Kelvin. To do this by hand calculation first, we're going to rearrange our equation to solve for the thickness of the wall. We know that the thickness is going to equal that resistance times our thermal conductivity. But our thermal resistance is equivalent to 1 over our thermal contact conductance, which is a known variable. So we're going to plug that in instead. Then we're going to plug both of our known variables in, and we are going to calculate that it's 0.016 meters, and then we're going to multiply that by 1,000 for ease, and see that our answer is 16 millimeters. Next, we're going to solve this using Python. We're going to set up our thermal resistance as 1 over 11,000, which is, of course, equivalent to 1 over our thermal contact conductance. And then we're going to set our thermal conductivity equivalent to 176. Then the thickness of our plane wall we're setting as the variable length, and that's going to be our thermal resistance variable times our thermal conductivity variable times 1,000 for that unit conversion at the end. Then we're going to print our variable length, and we're going to see that 16 millimeters is the length that Python tells us is the thickness of that plane wall. So overall, we can see that our Python calculation and our hand calculation both resulted in a 16 millimeter thick aluminum wall that would give us an equivalent thermal resistance.